Hey everyone, today we're talking about solving rational equations. Just kind of a little recap about domain because we are going to be talking about domain some in this lesson. Um, what is the domain of a function? Remember, domain of a function is everything that it could possibly be or put into it uh, in order for it to be a real number. So mainly just a set of x values. You think of it that way. Set of x values. Sometimes there's restrictions, sometimes there's not. But the big thing is we cannot have 0 in a denominator because it's undefined. Therefore, any value that we make in the denominator equal to 0 must be removed from the domain. This is called an extraneous solution. To find a domain, we set the denominator not equal to 0. You might remember this from the previous chapter. And find the x values that need to be removed from the domain. So here's example 1. Find the domain of each of the following rational expressions. In order to find the domain of example number 1, we first want to look at the denominator. The numerator has nothing to do with the problem, or at least how the domain is formed. So x squared minus 36, let's set that not equal to 0. We could solve this by factoring, or we could use root property. I'm going to opt for root property, it's a little quicker. And then take the square root of both sides, and I get x cannot be plus or minus 6. So if you remember from domain, we could either write it as all real numbers, where x cannot equal plus or minus 6, or we could write it in interval notation, negative infinity to negative 6, negative 6 to 6, or 6 to infinity. If you take a look at the difference here with example 1 and 2, example 1 has an x value underneath, and example 2 does not. So therefore, in example number 2, our domain would be all real numbers. Or if you wanted to put it in interval notation again, negative infinity to positive infinity. The reason behind this is because you could plug in any number for x. Your denominator is always still going to be 2. So therefore, you can plug in any number you want to. Whereas in example 1, if we plug in a 6 or a negative 6 into the bottom, it'll become 0, which will have a number over 0, which is an undefined value. So here are some steps for solving. I could read through them, but I think it's probably best to kind of go through a couple of the problems. Just as a recap, you will need to use an LCD with these. And then in order to solve, we need to make sure that we determine the extraneous solutions by setting the denominators not equal to 0. Okay. We can also lastly find solutions to then check with the domain restrictions. So take a look at solve each of these equations. This is going to be a very simple cross multiplication type problem. But before you do that, I just want you to take a look at your domain. If you notice on this side, x minus 3 cannot be equal to 0, so x itself cannot be equal to 3. Over on this side, x minus 2 cannot equal 0, so x cannot equal 2. So our domain really, for both of these, is all real numbers. X cannot equal 3 or 2, or 2 or 3, either one. All that's telling us is that if we get an answer of 3 or 2, that answer is called an extraneous solution, and we throw it away. So let's cross multiply. X times x minus 2 is equal to negative 2 times x minus 3. So x squared minus 2x is equal to negative 2x plus 6. I'm going to add 2x and subtract 6 from both sides. So again, x squared, those will cancel, negative and positive, both 2's, minus 6 equals 0. I wanted to set it equal to 0 because I do want to solve for my x value. So x squared is equal to 6, and then square root that. So x is equal to plus or minus the square root of 6. Since the square root of 6 plus or minus is not 3 or 2, then that's a solution. Yay! Okay, take a look at example number 2 here. In order to simplify using the cross multiplication, we need a common denominator. So this is where the LCD comes into play. We're mainly just looking at it for this this left side. So if you notice here, we've got a 3 in our left fraction, and then our right fraction, we have the x. So I'll need to multiply that one by x on both sides. And then over here, I'll have to multiply this by 3 over 3. I know I can simplify 6 over 3 to become 2. I'm going to hold off right now. So right now I'll have 5x squared plus 21 over 3x is equal to 6 over 3x. Now what's kind of cool about this is since both of them have the same denominator, I can actually cancel them out. Why that happens, just kind of show you the math behind it. 6 times 3x is equal to 3x times 5x squared plus 21. Since they both have the 3x, if I divide each side by 3x's, gone. So now I'm left with 6 is equal to 5x squared plus 21. I'm going to subtract 6x over to the other side. And 21 minus 6, I can actually backtrack a little bit there. 21 minus 6 is going to give us 15. So now that everything is set equal to 0, I can subtract 15. So I didn't even have to move the 6 if I didn't want to. I get negative 15 is equal to 5x squared. Divide by 5. I get negative 3 is equal to x squared. And then I'm going to take the square root. So x is equal to plus or minus I root 3. Now here's the deal. Yeah, that's kind of an answer. Okay, we can't really have a negative underneath of a radical. If I plug that back into my equations, I would definitely not see anything that would give me 0 in my denominator. My domain for my denominator, okay, regardless of 3x or 3x, 3x cannot be equal to 0, so x cannot be equal to 0. So it would be all real numbers where x cannot be equal to 0. So whenever you get an I, an imaginary, okay, don't know what happened there. Okay, we can use it as a solution, but usually we just say that would work whenever we plug it in. Let's go ahead and take a look at example number 3 here. Okay. Now I need a common denominator. So this is 1. I'm actually going to multiply 1 by x plus 3 over x plus 3. Apologize for the little bit of a lag that I have. And now I can combine everything into one fraction. So I have 2x minus parenthesis x plus 3 all over x plus 3 is equal to x over x plus 3. Right? They both have the same denominator. As I said before, if they both have the same denominator set equal to each other, we can cancel those out. I'll be left with 2x minus x minus 3, because they do have to distribute, is equal to x. So x minus 3 is equal to x. Whoa, look at this. I subtract x from both sides. I get negative 3 is equal to 0, which won't work. So this is going to be no solution. All right, when we have a problem like this, again, remember our domain. We need to look at that domain restriction regardless of whether it's no solution or not. So if x plus 3 not equal to 0, x cannot be negative 3. So our domain could be all real numbers, except x cannot be negative 3. If you have to pause the video at all, you definitely can. Fast forward or rewind or do whatever. All right, example number 4 gets a little bit more intricate. I'm not going to say the word difficult. It gets a little more intricate. The reason being is because you have to factor x squared minus 4 into x minus 2 times x plus 2 to start. From here, then, we can find an LCD. And an LCD, it looks like it's going to be x plus 2 times x minus 2. So let's do this. We're going to take, I'm just going to rewrite the problem here. Now, on my right side, okay, anything on the right side of the equals, it's one fraction. I don't have to worry about combining any terms or doing any, like, two different fractions, combining them into one. So really the only thing that I need to do on this left side is multiply this fraction by x minus 2 on top and bottom, because that's what it doesn't have compared to the other fraction I'm trying to combine it with. So I'll rewrite this of x minus 2 times x minus 8 over x minus 2 times x plus 2 equal 2 over x minus 2. I'm going to simplify my top here. So off to the side, I'm going to simplify this. This is going to be x squared minus 2x minus 8. So now I'm going to put that in x squared minus 2x minus 8 over x minus 2 times x plus 2 is equal to 2 over x minus 2. Okay, if you have something in the denominators on each side of the inequality, for example here, I have an x minus 2 here and I have an x minus 2 here. They're both the same. They can cancel out because when you cross multiply, you'll divide by those anyway, and they will be eliminated. So these are going to go bye-bye. Okay, we're going to cross multiply. This will become a 1 naturally, 2 over 1. So then I'll be left with x squared minus 2x minus 8 is equal to 2 times x plus 2. I'm going to distribute. So I get x squared minus 2x minus 8 equals 2x plus 4. And then I'm going to subtract 2x from both sides and a 4. So I get x squared minus 4x minus 12 equals 0. I can factor that. What's going to multiply it to give me negative 12 and add to give me negative 4? It's going to be x minus 6 and x plus 2. So then x minus 6 equals 0. X plus 2 equals 0. So x is equal to 6. And x is equal to negative 2. Or is it? So one thing that I didn't do in this problem yet is find my domain and my domain restrictions. So taking a look at my LCD, or some of my denominators that I do have, I have to set up my domain restrictions, okay? So I'm going to write my domain. This is where I'm going to put my domain. But I'm going to do the work up here. X plus 2 cannot be 0. X minus 2 cannot be 0. So x cannot be negative 2. And x can also not be 2. Uh-oh. Look at this. We can't have that happen. Well, we can. All it's going to tell us is that, first off, our domain is all real numbers, except for x cannot equal -2 or 2. And it also tells us that because that -2 is a domain restriction, this is no longer a viable answer. So the only answer that we'll be allowed to have is x is equal to 6. All right. Okay, I know that was a lot, so if you have to fast forward or rewind the video, you can. Last example that I have for you, example number 5. Okay, we need a common denominator, so let's get that LCD. Looks like x minus 2 and x minus 3. So I'm going to just rewrite my problem on the left side because I want to multiply this by x minus 3 and x minus 3. And on this side, I'm going to multiply by x minus 2 and x minus 2. Now let me back up and use a different color. On my right side, I need to factor that bottom. So what's going to multiply to give me 6 and add to give me -5? It's x minus 2 and x minus 3. Nice. All right. Combining this whole fraction together. X minus 3 times x minus x times x minus 2 all over x minus 3 times x minus 2 is equal to 3 over x minus 2 times x minus 3. On the left top numerator, okay, I want to distribute. I want to simplify. So this is going to give me x squared minus 3x minus x squared plus 2x. And I'm just going to set that equal to 3. If you take a look, okay, at what I'm about to circle in green, this denominator and this denominator, they're the same, okay, and they're on different sides of the equality, which once again, okay, means that if I were to multiply, cross multiply, they would cancel each other out, so you don't need to do that at all. That's just an extra step, okay? I'm trying to save you work. Work smart, not hard. So let's simplify this. I've got an x squared minus an x squared. See ya. Those are gone. And then I've got -3x and 2x, which is going to give me -1x equal to 3. I divide by -1, and I get x is equal to -3. I'm done, right? Wrong answer. Okay, we need to find the domain. And if you look at each of all those different denominators, the two things that stand out are x minus 2 and x minus 3. We need to make sure that they're not in our answer. So x cannot be 2. X cannot be 3. So our domain will be all real numbers, except where x is 2 or 3. That can't happen. And it just so happens that our answer is -3, not a +3. So that can be our solution. Thank you for watching. Again, if you feel like I went too fast, maybe you just need a refresher, please feel free to stop the video, hit the rewind button, or the little cursor thing, the new age stuff, and check it out. And you can always ask me questions during class.